ओके दोस्तों, ये क्वेश्चन देखते हैं। ये आपका गेट 2017 सेशन 1 में आया हुआ है। ठीक है, मतलब सेट 1 में आया हुआ है आपका ये क्वेश्चन। इसमें आपको क्या बोल रहा है? This consolidated undrained triaxial compression test is conducted on normally consolidated clay at a confining pressure of 100 kPa. Okay, so CU test has been performed, that is consolidated undrained triaxial compression test has been performed on a normally consolidated sample. Okay, the clay is going to be normally consolidated clay. Okay, now the question has specified that the sigma 3 value is going to be 100 kPa, that is the confining pressure. All you know that first of all we apply a confining pressure and that is known as sigma 3. So sigma 3 has been given as 100 kPa. Now the deviatoric stress at failure is 80 kPa. Suppose this is the soil sample and the soil sample is of normally consolidated. First of all, you have applied a confining pressure all around the sample. So I have also applied a confining pressure all around the sample and its magnitude is going to be what? 100 kPa. So this is nothing. So this is the 100 kPa. Now after this stage, that is the consolidated stage is this one. After that you have applied a deviatoric stress. So deviatoric stress is going to be applied like this in extra 2, and this deviatoric stress will be applied on this plane, this horizontal plane. Okay, only on this horizontal plane only. So on this plane, this is the sigma d that has been applied and this is the deviatoric stress. So tell me what is the value of the stresses on the sample. So this is the sample and here you can see that you have applied only sigma 3. So sigma 3 is this one, and over here you have applied sigma 3 plus sigma d and this is nothing but sigma 1. Okay, so what is the value of sigma 1? Sigma 1 is going to be sigma 3 plus sigma d, and what is sigma 3? That is 100 plus 80 and this is 180 kPa. Okay, so sigma 1 is going to be 180 kPa. Now after application of this deviatoric stress, you have just closed the drain valve, due to which pore water pressure has been generated. Pore water pressure has been generated. ठीक है? After this, what is the pore water pressure that has been generated? So pore water pressure is going to be 50 kPa. Now if you uh, recalled na, this sigma 3 is nothing but total sigma 3, and this sigma 1 is also what? Total sigma 1. And if we use, like, we have to calculate what is the effective angle of friction. If we perform the total stress analysis, means this type of analysis can be performed in two ways. First is total stress analysis. In this total stress analysis, you use all the total stress parameter. Like if I use sigma 1, so this is going to be what? Total stress. Now we can write this sigma 1 as 2c cos phi by 1 minus 1 plus sin phi plus 1 minus sin phi by 1 plus sin phi. No, sorry. It is going to be 1 minus sin phi. And here it is 1 plus sin phi by 1 minus sine phi. Oh, something is wrong na. 2c cos phi by 1 minus sine phi. Let me check. Okay, this is the correct one. 1 minus sine phi. So sigma 1 is equal to 2c cos phi by 1 minus sine phi plus 1 plus sine phi by 1 minus sine phi, and this is nothing but sigma 3. So this, if you use this as a total stress, total sigma 3, and this as total sigma 1, so we have performed the total stress analysis. Okay, and this is going to be the total strength parameter, that is C and phi. But when we perform the effective stress analysis, second one is the effective stress analysis, effective stress analysis, then in this case also this equation holds true, but this should be in the effective stress, like sigma 1 effective. Okay, this relation will holds true between sigma 1 and sigma 3, but these two parameters should be in effective stress parameter, that is sigma 1 dash is equal to 2c dash. This is the effective shear strength parameter. Okay, so effective shear strength parameter, that is c dash and phi dash. Okay, so this effective angle that you have been asked to calculate, you can calculate this effective angle of internal friction only in case of effective stress analysis. Okay, so this is nothing but sigma 1 dash is equal to 2c dash into cos phi dash by 1 minus sine of phi dash plus 1 plus sine phi dash by 1 minus sine phi dash, and this is nothing but sigma 3 dash. So all the parameter I have written in terms of the effective parameter. So what will be sigma 1 dash? Sigma 1 dash will be nothing but sigma 1 minus pore water pressure. So here sigma 1 is 180. Here sigma 1 is 180. You just divide, subtract what pore water pressure into the total stress. So you will get the effective sigma 1. Similarly, you can find what is sigma 3, and this is nothing but sigma 3 minus pore water pressure. So what is sigma 3? 100 minus 50. So this is 50 kPa. Alright, now you just substitute. One thing is that for normally consolidated soil, if you perform CU test, in CU test what will be the value of C? C is going to be 0. So only 5 value you will obtain for normally consolidated soil. But for over consolidated soil you will get C and phi both. So for normally consolidated, what is this? C dash is going to be 0. So simply the equation will converge like this. Sigma 1 dash is going to be 1 plus sine phi dash by 1 minus sine phi dash into sigma 3. Now substitute the value. This is 130, 1 plus sine phi dash by 1 minus sine phi dash, and this is what? 50. So what will be the value? Just after substituting, this is 50, this is 1 plus sine of phi dash by 1 minus sine of phi dash, and after just simplifying you will get like 5 plus 5 into sine of phi dash. So what will be the value? 13 minus 5 is equal to 5 plus 13 into sine of phi dash. So sine of phi dash is simply what? 8 by 18. So phi dash is going to be sine inverse 8 by 18. So what will be the value? So this is nothing but 26.387 degree. So you have to write this answer up to in degree up to one decimal place. So the correct answer is going to be 26.4 degree. Okay. So in this way I am continuous solving the problem of previous gate year question. If you like the video, you just have to like the bell button. If you unlike the video, just write the comment why you are unliking, and also share amongst yourself so that this will be benefited, this video will benefit to all the requires a student who requires the tutorial right now. So share this video also.